Why do we see tension and compression almost always working together in stable structures around us? Whether it's a bridge, a table, or even the very act of walking, we often find these forces paired together. In the framework of energy filament theory, this pairing is not merely coincidental, but rather a result of the energy's fundamental rules. The theory states that tension and compression are the opposite ends of a continuum, and they work together to balance and maintain the energy ledger of a system. In other words, tension and compression are not isolated forces but interdependent, and they are both essential to maintaining equilibrium. To understand this, let's break it down further. Imagine you're setting up a simple tent with poles. When you pull the rope to extend the tent, you might think that only the ropes are under tension, but if we dig deeper, we see the entire structure at play. The ground beneath the tent is being compressed. The poles are being bent, and the fabric of the tent is being stretched tight. The force you apply to the rope is just the entry point into a larger energy system that involves tension and compression across the entire setup. The rope's tension is only effective because it forces the system to change, but the compression at the base ensures the system holds its shape. Without the compression working in tandem with the tension, the system would collapse or fail in some way. Now, imagine a scenario where you're pulling a rope attached to a wall. It may seem like you're simply pulling on the rope, but in the language of energy filament theory, there's much more happening. Your hands, the rope fibers, the walls, and the ground form a closed energy loop. When you pull the rope, you create tension at your end, but simultaneously, the wall is being compressed, and the ground beneath it is bearing the force of that compression. As you pull, the energy is redistributed throughout the system, creating a flow of forces that must balance each other. If any part of the system is unable to cope with the tension or compression, it will break, showing us that forces are interwoven and cannot exist in isolation. Bridges also provides a perfect example of how tension and compression work together. In a suspension bridge, for instance, the steel cables experience tension while the towers and piers beneath them undergo compression. When cars drive over the bridge, the forces of tension and compression are redistributed through the structure, affecting its stability. Similarly, in a truss bridge, each diagonal rod either experiences tension stretching or compression squeezing. The bridge, as a whole, works like a finely tuned instrument, where every part plays its role in maintaining the overall balance of the structure. If one of these forces is missing, the whole system would collapse, and the tension-compression cycle would be broken. Think about your own body as well. Your muscles are designed to pull, not push, which is why your bones are responsible for bearing compression. Every time you lift your arm, stand up, or jump, you are essentially managing a system of tension and compression in your body. The muscles stretch and contract, while the bones bear the compression that helps maintain your form and movement. Without this balance of tension and compression, your body would not function properly. This interplay is at the core of how we move, stand, and carry out everyday actions. Tension and compression are essentially two sides of the same coin. In any system, for every stretch or elongation tension, there must be an equal amount of compression or squeezing to keep everything in balance. For instance, when you push a heavy object, you're forcing it to move along a path where tension and compression balance each other out. In this case, the energy doesn't simply disappear, nor does it increase. It's just distributed in such a way that the forces are in harmony with one another, even though we might not see it with the naked eye. The interaction between tension and compression is what keeps everything from falling apart. So, the next time you look at a solid structure, whether it's a piece of furniture or even a building, remember that tension and compression aren't just isolated forces. They work together, always balancing each other, making sure the energy ledger of the system remains in check. The real question isn't where the forces come from, but how they work in tandem to create stability. That's the true magic behind how everything from simple objects to complex structures remains intact. Tap follow, share it on New Physics, Clear Universe.